Welcome everyone in this lecture about receiver function studies of crustal structure, composition, and evolution beneath the Afar Depression, Ethiopia. This is my PhD dissertation that I did in 2011 at MST, Missouri University of Science and Technology. This is the outline. I will start talking about the aims of the study, then the importance of the Afar Depression, then the method I used, which is receiver function analysis, data, the results, and the implication of the observed results, and finally the conclusions. The study aimed to find the crustal properties beneath the Afar Depression by measuring the following three parameters. Number one is the crustal thickness. Number two is the composition of the crust from calculating Poisson's ratio. And finally, the sharpness of moho, R, where R is the amplitude of the converged faces from the moho. This is a map showing the Afar Depression, which has the shape of a triangle and covers an area of around 200,000 kilometers square and is a part of the Arabian Rift system. The depression is located at the northeast side of Africa and includes two oceanic ridges, which is Gulf of Aden and Red Sea, and a continental rift, which is the main Ethiopian rift. The geology of the area are mainly Cenozoic, volcanic, and sedimentary rocks. The importance of the Afar area. Number one, the unique of the geological history and tectonic setting. It also represents the only emerged rift triple junction in the world beside Iceland. The characteristics of the crust beneath Afar have been a subject of a controversy among scientists. Afar is an example of a transitional stage from continental rift to seafloor spreading, and finally the high teleseismic data sets that are available from 18 broadband seismic stations that we deployed. Receiver function analysis. Receiver function analysis is a well-established technique to estimate crustal and upper mantle structure using three-component seismic data. The analysis detects the crustal boundary by identifying the P to S converted wave and their multiples. From this figure, we can frequently observe the primarily convergent PMS and the multiple phases, the PPMS and PSMS. The multiple phases are weaker than the PMS wave, and therefore they are hard to recognize. I have deployed 18 Gorlab CMG3T broadband seismometers along a profile of 215 kilometers long with a station spacing of 10 kilometers. The instruments recorded data at 100 samples per second for 12 months period from December 2009 until December 2010. The stations have been visited and serviced twice in June 2010 and December 2010. The equipment used for the installation is the sensor, the Q330, the baler, the clay, the battery, the power box, the solar panel, and finally the GPS. Again, this picture shows the content of each station, the Q330, baler, the battery, and the power box. The stations were either inside a box for a protection purpose or inside a barrel if it is inside someone's properties. If it's inside a box, the Ethiopian colleague writes down the information in case of emergency. This map shows the distribution of the seismic station in the Afar Depression, showing the Tindaho Graben and the Dubi Graben by using Google Earth. Tindaho Graben is 150 kilometers long and it's wide between 25 to 50 kilometers, while the Dubi Graben is narrow about 50 kilometers long and 12 kilometers wide. Both has north, west, southeast trending faults. Observation of H, R, and sigma were obtained at most of the stations. P to S convergence from the MOHO can be observed on the majority of the stations from the stacked receiver functions. The results were organized into two categories, A and B, based on the quality of the H-phi plots. Category A stations display a clear defined single peak in the H-phi plots, where H and phi can be determined, while category B station show clear PMS but not PPMS or PSMS. So H and phi cannot be determined. Category A station display a clear defined single peak in the H-phi plots. And as we can see that category B station show a clear PMS but not PPMS or PSMS waves. The results of the HK stacking are divided into three divisions. Stations southwest of Tindaho Graben, the Tindaho Graben station, and the Dubi Graben and the adjacent Horst station as seen in this figure. This table shows that the station southwest of the Tindaho Graben has the crustal thickness beneath this station ranging from 25.33 kilometer to 35.22 kilometer. The phi values ranges from 1.844 to 1.988. The R values observed are from 0.069 to 0.181, while the Tindaho Graben station, the crustal thickness ranging from 23.49 to 27.40 kilometer, the phi values ranging from 1.921 to 2.071. The R values observed are from 0.017 to 0.302. And finally, the Dubi Graben and the adjacent Horst station, the crustal thickness ranging from 27.64 to 31.99 kilometer. The phi values range from 1.870 to 1.984. The R values observed are from 0.068 to 0.265. Map the resulting crustal thickness H, where the circles represent station with a smaller thickness and the plots represent station with larger thickness. Those observations show that the average crustal thickness is around 28.56 kilometers. The resulting crustal VP over VS for category A station, those observations show that the average VP over VS for the entire study area is around 1.94, and the Poisson's ratio ranging from 0.29 to 0.34, while the resulting ratio R, those observations show that the average R is around 0.144. This figure also, which is the cross-section plots for elevation and H, the figure show that the Tindahu Graben has the thinnest crust than the Dubi Graben, which is associated with the presence of the mantle plume. While the figure show a cross-section plot for VP over VS and R, it's observed that the Tindahu Graben has the highest value of VP over VS, and it turns out that the values are low away from the Graben. While this figure shows the resulting Booger anomalies model, it is observed from the gravity anomalies that the area of thin crust are associated with higher gravity anomalies, while thicker crust have small and negative anomalies. Summary of the results. The average crustal thickness is around 28.56 kilometer. The phi value ranging from 1.84 to 2.07, with an average of 1.94 and Poisson's ratio ranging from 0.29 to 0.34. The resulted Poisson's ratio obtained in this study is consistent with the estimation of Rouge at the year of 75 of the value of 0.28 to 0.33, Zanid and Amun in 1995 of the value of 0.29, and Dugda and Niblad in 2006 of the value of 0.30. The gravity minimum occurs over the area of higher elevation negative, while the value increases toward the Tindahu Graben. The gravity modeling results are consistent with the distribution of crustal thickness and the observation of VP over VS using receiver function analysis. The study indicates that the crust layer beneath the study area in the Afar Depression is composed mainly of more mafic material and contains a small amount of partial melt. The phi distribution is remarkably large throughout the area and seems to have a clear relationship with the crustal thickness, meaning the smaller H corresponds to large VP over VS and vice versa. The more mafic component occur in the crust, the thinner the crust will be. The mean values of VP over VS for the stations located southwest of the Tindahu Graben and in the Tindahu Graben are considerably larger than those in the Dubi Graben. It's likely that magma source exists in the crust that lead to rise the values of sigma. This figure of relationship between the result VP over VS and H show small value of VP over VS, and the thinnest crust has the largest value of VP over VS. The Tindahu Graben has a thinner crust comparing with those southwest of the Tindahu Graben and the Dubi Graben. The distribution of crustal thickness go together with reasonable rational with high elevation areas. The Afar Depression has smaller than normal stacking amplitudes of the P to S converted faces beneath most stations. The study assumed that diking is more likely the cause that rise the observed high value of VP over VS. The average crustal thickness beneath the Afar Depression is about 28.56. The crust is characterized by large VP over VS of 1.93, smaller than normal overall sagging amplitude of P to S converted faces beneath most station. The crusts beneath the entire study are significantly thinned and extensively intruded by mafic dikes, representing a transitional stage between continental and oceanic crust. The Tyndall Graben has the thinnest and most mafic crust. The crust beneath the center of the Tyndall Graben is likely to be oceanic type and become progressively more continental away from the center. Active magmatic areas like Tyndall Graben are characterized by high gravity anomalies, while the thicker crust have small and negative anomalies. The observed phi values in this study seem to have a clear relationship with the crustal thickness, meaning smaller H correspond to large VP over VS. The study assumed that diking is more likely the source, which causes the elevation of phi values.